Hello everyone. My name is Rajneesh Singh, and today we are with our new video. And let's get started. What if I told you that you could predict the future of a completely random system using just a little bit of math? Sound impossible, right? But actually, you can. Today we are diving into the fascinating world of Markov chains, a powerful idea that help us to find patterns in what look like pure randomness. Let's get started. Here is what's the plan. First, we will look into a simple puzzle, a random walker. Then, we will build the mathematical rulebook behind it. After that, we will learn how to predict the future. And finally, we will explore what happens in the long run. And trust me, there are some surprising results waiting. We are not starting with heavy maths. We are starting with a character, a random walker. The person has zero memory of where they have been. Imagine a drunk person walking on a straight line. There is a drunk person who is walking throughout a straight line, and at each step they go left or right, each with a 50% of chance. Seems completely random, right? But here is the question. Can we still say something about where they will be after 100 steps? Here is the key, the secret sauce. This walker has no memory. They don't care about the previous 99 steps. The only thing that matters is where they, where they are right now. This is called memoryless process, and this is the heart of every Markov chain. To make prediction, we need rules. In math, we represent these rules using something called a transition matrix. Think of it like a cheat sheet. It tells you the probability of moving from one state to another. It is a simple table of probabilities in it. This matrix follows two simple rules. All values are between 0 and 1. Each row adds up to 1. Why? Because from any state you must go somewhere. So the total probability is 100%. For our walker, 0.5 probability to move left and 0.5 probability to move right. 0 probability to stay at the right same place. The idea isn't just theoretical. Markov chains are used in Google page ranking, like whenever you see any websites and the ranking for the websites. So it is based on the Markov chain. Apart from it, in physics, the particle of any movement, in biology, the DNA evolution, in financial models, there are so much use cases of Markov chain. So yeah, this is kind of powerful stuff. Now comes the magic. We combine the memoryless idea and the transition matrix. First, we will start with a vector, a list of probabilities at time 0. To find the next step, we multiply P0 by the matrix. This gives us P1, the new probabilities. Now, here are the powerful part. First step, multiply once. N steps, multiply n times. So, future after n times becomes P0 into matrix to the power n. Predicting the future becomes just a math calculation. We took a messy random process and turned into a clean math. Now we predict 10 steps ahead, 100 steps ahead, even 1000 steps ahead. Now a bigger question. What happens if we let this run forever? Does it keep changing forever or settle down into something stable? In many cases, the system settles down. It reaches something called a stationary distribution. This is a stable state where multiply again and again gives the same result. It is like an equilibrium which is formed. Initial distribution, where you start. Stationary distribution, where you end. These are the important insights which you must remember. And surprisingly, many systems forget where they started. But here is the twist. Not every system settles down. Imagine this. From A, always go to B. From B, always go to A. What happens if it keeps going on A to B, B to A, then again A to B and B to A forever? no stability, just flipping back and forth. So, here is the big idea. Not all Markov chains converge. Some settle into a stable state and others keep oscillating forever. So, now the bigger question is, what decides the system fate? And why do some systems stabilize and why do others keep cycling? The answer to these questions you may find in the transition matrix. The structure of the transition matrix is the answer to these questions. I hope you get some insightful points from this session. Thank you for watching throughout the video.